going forward. The first of these, titled Observed Trends and Future Climate Projections of Extreme Climate Indices in the Dry Zone, will be presented by Dr. Shiromani Jayawardena, National Consultant for Adaptation of the Project for Enhanced Transparency Framework for the AFOL Youth Sector, Climate Change Secretariat and Director, Department of Meteorology, retired. Dr. Shiromani Jayawardena, a meteorologist, has more than 24 years of experience in the field of meteorology and possesses a good record of working with international agencies. She is a member of several international and national technical committees related to climate change, adaptation, and climate services. She was the director of the weather forecasting at the Department of Meteorology in Sri Lanka from 2020 to 2023. Presently, she is attached to the Climate Change Secretariat as a national adaptation consultant to the project of Enhanced Transparency Network, ETF, for the AFOL Youth sector. Her research interests are climate change, climate variability, and future climate projections. I would now like to cordially invite Dr. Shiromani Jayawardena to present her work.
Thank you very much for the nice introduction. Okay, so my topic today is to talk about the historical trends and future climate projections of extreme climate indices in Sri Lanka. For active adaptation, we need to identify the risk first. Then to address that risk, we have to develop plans, strategies, and then implement action. So historical trends provide us information about how climate has already changed, and future climate projections shows us how it will evaluate in the future. So these are the outline of my presentation. First, let me talk about the global projections of climate risk. These are actually based on the latest Intergovernmental Panel of Climate Change report, assessment report, 6th assessment report. So if you consider carbon dioxide concentration, it is the highest at, if we compare to the last 2 million years, now we have highest carbon dioxide concentration in our atmosphere. Then sea level rise is fastest during last 3,000 years, and then Arctic sea ice decline is also lowest level at past 1,000 years, and glacier retreat also unprecedented if we compare with the last 2,000 years. So the global exposure to multi-sector risk will be 4 times more if we go for 1.5 degrees to 3.3 degrees warming in future. So according to the IPCC report, that excess warming arises due to this anthropogenic warming absorbed by the ocean, 90% absorbed by the ocean, then land absorb 5%, melting ice sheets goes 3%, and on atmosphere only absorb only 1%. According to their report, ocean will absorb 2 to 4 times more heat if we global warming is, even though if we limit to 2 degrees, and 5 to 7 times higher in higher emission. So we cannot avoid this ocean acidification, extreme ENSO events. Like at present, we are also experiencing the El Nino in the Pacific Ocean, and then changes in tracks and intensity of tropical cyclone, shift in fish population, and this affects the food security. And if we consider the land, current level of warming, there's a moderate risk of increase in dryland water scarcity, soil erosion, vegetation loss, fire damage, coastal degradation, and crop yield decline. At 2 degree level, the risk for the food instability will be very high, and at 3 degree level, there will be a high risk for vegetation loss, fire damage, dryland water scarcity become very high. So let's discuss about the trends, temperature and rainfall trends. If you compare the literature. So there are some consistency about the increasing trend in temperatures. Many publications identified that increasing trend in temperatures in Sri Lanka, but when we compare to the rainfall, there are different findings. Some mentioned that no coherent increase or decrease in rainfall trend, decrease in trend in annual rainfall stations in southeastern and southern part, decrease in rainfall at high elevation and increase in rainfall in lowlands. So this type of different findings there. Because the reason is actually they have used different methodologies and different time periods. So to address that, World Meteorological Organization, they developed this extreme climate indices. So based on different using temperature and precipitation, using different type of indices, like there are some percentile indices, absolute indices, threshold indices, duration indices, and other indices. So these indices, they have developed the software also, so any country can run. So we can compare because there is a consistency about the methodologies and everything. So when we run these indices to Sri Lanka, this study is actually for whole Sri Lanka, but unfortunately we couldn't use Jaffna data because we have more than 10-year gap in missing data in the Jaffna because of the conflict we have experienced few decades ago. So because of that conflict we don't have data, so we cannot run this for the Jaffna. So except that other stations actually we have run. So it shows us different findings. Increasing of temperature is evident, like I mentioned earlier, it's obvious but one important thing is the difference between maximum temperature and minimum temperature, that is day temperature and night temperature, we found decreasing trend. That means night temperature is increasing faster than day temperatures. That is obvious in the dry zone as well as in wet zone. So I think this agricultural people knows how important of this diurnal temperature range, especially for potato. And then when we run this for the this rainfall indices, it shows us there is an annual rainfall, there is an increasing trend even in the dry zone. Here the red triangle shows us the increasing trend. A larger triangle, that is under the 95th confidence level, and this small one, the 90th one. So 75% of the stations show significant trend of increasing annual precipitation. But other thing, important thing is that we can give some thresholds like about 10 millimeter rainfall, 20, 30 like that. So this also we show increasing trend. And when we consider the extreme rainfall, so we found most dry zones, like here we have Anuradhapura, Trinco and Batikro, where it shows significant increasing trends in daily intensity of rainfall, and there are some other indices like maximum of rainfall above 95th percentile, rainfall above 99th percentile, and then 5-day consecutive rainfall. So these shows increasing trend, especially in the Anuradhapura and Batiklo shows us a very significant increasing trends. Actually climate change, it shows us like changes in rainfall. There will be more and more extreme events related to rainfall as well as temperatures. So it will impact agriculture, water, industry, health and ecosystem. So we need to go for mitigation to reduce greenhouse gases as well as to address the vulnerability. Actually we need to know what has happened based on the trends I have explained earlier, as well as based on the future climate projections. So the climate models or Earth system models can run for next 100 years, and it gives us some idea about what will happen in future. For future climate projections also important, it gives us what does the future hold? So they develop this type of climate models. So the important part of the climate model, because these climate models run for like whole globe as well as for next 100 years future as well as past, because we need to compare this results with our observed rainfall, then only we can get idea how well these models can predict our rainfall. So that resolution is important. So this is how it evolution of these climate models. Earlier actually it was like 500 kilometers. So whole Sri Lanka will be in 1 or 2 grid boxes. So each grid box gives us one value for rainfall, temperature and other climate variables. So it's very important to go for a high resolution model. So right now actually they have increased it up to 100 kilometer resolution. Some they have 50 kilometer also. So you can see how well it represents when it go for high resolution. In addition to that, when we talk about the future climate, we need to know what will be the greenhouse gas concentration in our atmosphere in future, because there are a lot of uncertainties, because this concentration of greenhouse gas is depending on our emission, the land use, land cover changes, then population, economic growth, technological development, whether we can easily access this renewable energy which can give us for a low cost. So then we will go for that, otherwise we will go for this fossil fuel burning. So there are a lot of uncertainties. So Intergovernmental Panel for Climate Change, so they have given several emission scenarios. If we truly fully mitigate, we will greenhouse gas emissions, we will end up with this one, and if we gradually do that, we will end up at this level, and if we go for like what we are already practicing, business as usual, we will end up at this level. So there are low emission scenarios, moderate emission scenarios as well as high emission scenarios. So for developing these projections for Sri Lanka, actually we downscale global models, because we don't have facilities to run this type of models. So global models we can downscale into our regional level. That means coarse resolution climate models, we can increase the resolution by downscaling, so which can be used for the impact assessment. So for that actually we have used 6 global models, one from Meteor France, then other one Japanese Meteorological Administration, and then 2 US models and 1 Australian models. So because when we compare with the model climatology with our observed rainfall, we found these 6 models are able to capture the bimodal pattern, because in Sri Lanka we have bimodal pattern of rainfall. We have 2 peaks, one in May, other one in October, November, so that they were able to capture, as well as they were able to capture our spatial rainfall pattern. And so using these 6 models, we developed future climate projections for 2 emission scenarios: moderate emission scenario representing RCP 4.5 and high emission scenario representing RCP 8.5. So we found that northeast monsoon rainfall is going to decrease in future, especially dry zone. It is very drastic decline based on this model predictions. So especially this eastern part of the country, they receive 40% of their annual rainfall from this northeast monsoon rain, and then first intermonsoon, March, April rain also we found it decline, especially under high emission scenario. Then southwest monsoon rain and this second intermonsoon rain, both we found increase in trend, especially this wet zone. We saw that very high amount of rainfall predicted in future. So regarding the southwest monsoon, it's consistent with the other global findings also, because most of the projections research findings related to the future climate projections, they identified this increasing in southwest monsoon over this region. Then second in the monsoon also we found increasing trend. Overall, regarding the annual rainfall, we found that especially short-term projections, next 20 years from 2020 to 2040, there's a declining rainfall in the dry zone, and but wet zone it's increasing. But when we go for long term, it shows us whole Sri Lanka we get increasing rain. But the problem is that this rain, especially because the unseasonal rain, especially over this dry zone, they comes from the thunderstorms. So thunderstorms are very short, develop in very short areas, which gives very high intense rain within like 1 hour or half an hour period of time. So that is the issue. It is not like normal monsoon rain which we experience throughout the day. When it's obvious that temperature is increasing, and when we run this heat wave frequencies, for actually we run only for Colombo because heat island effects also contributed for excess heat in addition to heat wave. It shows us we are not experiencing heat wave until 2030, but then under both emission scenarios we can see sharp increasing trend in heat waves over Colombo. So these are the extreme indices, like I mentioned earlier, for future projections over dry zone. So you can see mean maximum temperature is increasing up to 2100. Maximum of maximum temperatures, maximum of also increasing, mean minimum temperature also increasing. In addition to that, extreme rainfall indices like maximum 5-day precipitation amount, extreme wet days, that is number of days above 95th percentile, intensity of rainfall, and and very wet day precipitation and annual rainfall also. We can see that year-to-year variation. With the year-to-year variation, it shows some increasing trend. Decrease in trend we found actually the temperature range and number of cool nights and number of cool days. Those are decreasing, gives us decreasing trend. So because of this increase in trend in extreme temperatures and rainfall, so we will experience more and more floods and landslides, soil erosion, more runoff and less infiltration, as well as droughts also we can experience because this, even though it shows us increase in trend, it all comes from the extreme rainfall. For example, if some area the annual rainfall is 900, so if they receive like 100 rainfall for 10 days, it gives us like above normal rainfall. So the cumulative rainfall does not show us much because it's average accumulation of all. Then increase in temperature, there will be more energy demand, more heat-related health issues, less labor productivity, and more evaporation and evapotranspiration, water loss from soil, water bodies and plants. So these are the climate change impacts from developing countries on developing countries. So climate change will increase extreme temperature and temperature event changes in rainfall pattern. So will result more frequent flood as well as drought. For example, if you remember this last year, till August 28, there are like more than 100,000 people. Disaster Management Center actually they provide this water for more than nearly 300,000 people. But then in October, just after 1 month, they have to give, there were people, 75,000 people were affected due to the flood. So within short period, this type of drastic change we can experience it in future. So according to the 6th assessment report, new type of unprecedented extreme events can occur. due to climate change. It will be larger in magnitude, more frequent, and new extremes, different timing, new locations, and different timing and new combination. For example, if you remember the cyclonic Vandus, which was not crossed Sri Lanka, but it crossed Tamil Nadu coast. But the cyclone shielded Sri Lanka. That radiation was shielded by the thick clouds of the cyclone for 3 consecutive days, so which gives us very low temperatures. This cold weather affects the livestock industry, especially in the northern part of the country. So this type of because we have never experienced this type of cold weather associated with the tropical cyclones, but new type of extreme events also we can experience in future. So in addition to that, climate change will have an impact on all countries in the globe, but we are the most vulnerable countries. It will affect the population growth, poverty, and rapid aggravate the population growth, poverty, and rapid urbanization. So without serious adaptation, climate change likely to push millions of people further into poverty and limit the opportunities for sustainable development, escape from poverty. Climate change is likely to reduce economic growth in developing countries. Significant investments in climate change adaptation are necessary. That's why this forum we will discuss about how you have provide some adaptation strategy for dry zone vulnerable communities to overcome the effects of the climate change. Thank you so much.